Hi. Hi. My name is Yama. I'm very excited to be here. So thanks for having me. And thank you all for coming. I'm going to talk about songs analysis and show you a little bit of the huge amount of information we can extract from it, specifically regarding repetition in the lyrics. So first I'm going to talk a little bit about me and MyPart, where I work. Then we're going to see the motivation to discuss repetition. We'll define some building blocks that we can work with. We'll talk about what counts as repetition and how we extract a repetition-based structure. We'll look at different song structures and see what we can learn from them. And then we'll talk a little bit about music and finally about our models. So, I'm a data scientist at MyPart. I'm researching lyrical and musical song features. I have a bachelor's in mathematics and physics from Tel Aviv University, where I also play the saxophone in the Tau Wind Band. So apparently there's a problem in the music industry where they don't have enough good songwriters. Of course, some singers write their own music, but there are a few famous songwriters, and even though I say famous, I'm guessing you haven't heard of them. For example, Max Martin. He's a Swedish producer and songwriter that won Songwriter of the Year award for 10 out of the last 20 years. He wrote hit songs for Britney Spears, NSYNC, Katy Perry, Pink, Maroon 5, Taylor Swift, Justin Timberlake, and a few more. And if a singer can get someone to write good music for him, they might be in trouble. Now, these days, if you write a great song for Ariana Grande and you want to send it to her, you need to find that friend that her roommate's cousin knows someone that works for Ariana and hope that your song doesn't end up in the trash before anyone even listened to it. So, MyPart to the rescue, obviously with the power of AI. We have a platform that connects songwriters with performing artists. And for each artist that works with us, you can see some of them in the colored photos, like Aerosmith, Bruno Mars, Dua Lipa, Kelly Clarkson. We build a benchmark of songs that is composed of this artist's songs or songs she would have liked if they were hers. And then we extract a lot of features, lyrical, structural, harmonic, melodic, and our models are trained on this benchmark. On the artist side, they get sort of a Tinder of songs. Skipped a part. We prioritize the songs that are submitted to the artist according to the model's predictions. And then they see their Tinder of songs. In Israel, for example, we had a pilot with Ivri Lider. He asked his fans to write songs for him, and more than 1,000 songs were submitted. MyPart prioritized the songs, so Ivri only went through the top of the list and already found relevant stuff that he liked. Eventually, anonymous songwriters got personal feedback from Ivri and an opportunity to cooperate with him without having to go through a reality show. Now, I'm assuming there's a few songwriters here as well, so don't forget to go to our website after the meetup and submit your song to your favorite artist. Now, let's talk motivation. Why should we talk about repetition? Because it matters. This graph was taken from an essay written by Colin Morris called Are Pop Lyrics Getting More Repetitive? There's also a nice TED Talk. Morris analyzed a dataset of 15,000 songs that charted on the Billboard Hot 100 between 1960 and 2015. That's the x-axis. Now, the Billboard Hot 100 is the record chart published by Billboard magazine. It's based on sales, radio play, and online streaming in the United States. And it's a way for us to look at the best songs. The blue line represents all songs, meaning the top 100, and the orange line represents the top 10. How did Colin measure that repetitiveness? He actually did that by compressing the lyrics file and looking at the ratio of the size of the lyrics file before and after the compression. These are the percentages in the y-axis. Compression is a nice measure because it uses repeated sequences. So it's not only about which words repeated, but also about their order. Now, we can see that the songs are getting more and more repetitive throughout the years. And you might have heard that before, usually as criticism. But we can also see that the best songs, those that reached the top 10, were on average more repetitive than the rest in every year from 1960 to 2015. And that gap is widening. So I think we can agree that repetition is a good measure to talk about. And even if you don't agree, that's still what we're going to talk about. Now we'll define some building blocks that we can use throughout the talk. So we'll define a segment in the lyrics by the blank line separator. And by default, we'll call every segment a verse. And we'll define the chorus as the segment of the lyrics that repeats the most. The same way, we'll define a sentence in the lyrics as a new line. We don't care about punctuation for that matter. And we'll define a refrain as the sentence that repeats the most. So let's look at an example. In this song, You're So Vain by Carly Simon, we can see 4 segments in the lyrics. One of them repeats twice, so we call it the chorus. That's the segment in pink. And in the chorus, we have a line that repeats twice, which is You're So Vain. So in total, it repeats 4 times, which is the maximal amount of repetition for a line here. So we call it a refrain. So how do we define a repetition of a sentence or of a segment? We know it shouldn't be perfect repetition because we don't want a wandering comma or an extra word to call off a segment's repetition. And even if the chorus, for example, in one of its appearances ends with a few more "don't you," it should still be recognized as the chorus, right? And maybe if we'll consider the sentences, you probably think this song is about you, and I'll bet you think this song is about you, as similar, then it will be the refrain in the song. So we need to find an algorithm that checks the similarity of 2 strings, and a threshold that says when do we call 2 strings similar. So we ended up with Levenshtein distance, which is a string metric that measures the number of characters you need to add, delete, or replace to transform one string into the other. For example, if you would like to transform Justin Timberlake into Justin Bieber, all you have to do is replace the T with a B to get Justin Bieberlake, replace the M with an E to get Justin Bieberlake, and then delete the letters L, A, K, and E to get Justin Bieber. And if we give every action a score of 1, and remember that replacing is actually 2 actions, adding and deleting, we get that the Timberlake-Bieber distance is 8. Now we can just calculate 1 minus the score divided by the total length of the strings, and for Justin Bieber and Justin Timberlake, we get 73% similarity. Then after consulting our lyrics experts and testing a little bit, we got to the threshold of 70%, meaning if 2 segments or sentences are 70% similar, then we consider them similar. So for that matter, we consider the Justins similar. So back to You're So Vain that we saw earlier. The sentences you probably think the song is about you, and I'll bet you think the song is about you, are considered similar according to our 70% threshold, but You're So Vain still repeats more times. So the final repetition-based structure is, for this part of the song, is verse, chorus, where the refrain does not appear in the verses. And if we look at some other song structures, we can see that, for example, in Whitney Houston's Greatest Love of All, we have 3 segments, and each one of them repeats twice. So by the definition we gave, we can't call any of them chorus. Now, in this song, the refrain is the greatest love of all, which is also similar to because the greatest love of all, I found the greatest love of all, and it is the greatest love of all. So the structure is type 1 verse, type 2 verse, type 3 verse, and again from the top, where the refrain appears only in type 3 verse. And another example is Shape of You by Ed Sheeran, where we have 2 segments repeating the same number of times. And in that case, we will call the first one pre-chorus and the second one chorus. And in this song, the refrain is I'm in love with your body, and it appears only in the chorus. So the structure is verse, pre-chorus, chorus, and again from the top. So actually, the structure we extract is not based only on repetition, as we saw here, but also on rhymes and syllables, we differentiate between verses that have different rhyming structures. For example, a verse with no rhymes compared to a verse where every other line rhymes. And between verses with different stressed syllable structures, meaning where is the stress in the words, what we know in Hebrew as mil'el and milra. And after we combine all of that, we get the final lyrical structure. Now, we would imagine that music is a creative world with never-ending inspiration and unique ideas. But actually, not only the lyrics are full of repetition, like we saw, but most of the songs are built the same way. From both lyrical and musical point of view, they're repeating the same structure. This pie chart shows the structures of a few hundred songs, and as you can see, the blue part represents more than half of the songs that are built the same way as shape of U. Verse, pre-chorus, chorus. The second and third most common structures that you can see in red and yellow are verse, chorus, with a small difference between them. And this distribution is of the existence of a refrain in 10,000 songs. 70% of them have a single sentence with the highest number of repetitions. And the double refrain is when you have two sentences repeating the most. And that appears in only 13% of the songs. So if you want your favorite artist choosing your song, make sure it has a pre-chorus and a refrain in it. Now we can just apply this whole process of analysis on the music, right? And extract features regarding the repetition of musical segments, phrases, bars, chords, notes. So yes and no. First, we need to separate the song into two components. The melody and the harmony. The harmony is the chords you play on your guitar or your keyboard, and the melody is the notes you're singing. The separation is done using frequency and amplitude analysis, and then we need to transcribe the harmony and the melody into data we can work with. In that case, that means timestamp and note frequency. Then we can use some of the logic we used for the lyrical features. Other features that are unique to music include the melodic range of a song, which is the range between the highest and the lowest note. And this is also a main characteristic for an artist. When people mention Freddie Mercury's huge vocal range, they're talking about 4 octaves, compared to Taylor Swift, for example, that has a range of around 2 octaves, which is about the average vocal range. And another feature, this time from the harmony, is simply the percentage of unique chords. You can see examples for that in plenty of YouTube videos that show how you can play dozens of songs with the same 4 chords. Now, everything we mentioned until now is pre-processing and feature extraction. And now we need to find the right model for our problem. Now, since linguistics and music theory are both classical fields full of rules and definitions, we have a lot of features we know will be useful. And we don't want to lose their meaning through dimension reduction, for example. And we want to have labels, because our classes are not necessarily clustered. Here's a visualization of our embedded songs for 4 different classes, 2 singers and 2 bands. And as we can see, it could be that a class will include 2 data points that are far from one another. If one artist has 2 songs in different styles, like Why Don't We, that is mostly clustered at the top right corner, but also has a few songs on the left side. And on the other hand, it could be that 2 data points that are very close to one another are a part of 2 different classes, if 2 artists have songs that are very similar, like our 2 singers that are mixed on the left side. So the distribution of the data points is not enough to define the classes. And this is why we want labels, making this into a classification problem. Now, to wrap things up, and since I know you love repetition, I'm going to go back to the MyPart flow, now that we're more comfortable with the analysis we're doing and the problem we're dealing with. So, let's say the Spice Girls reunite, and they're coming to MyPart for art sourcing. Their people are building a benchmark for them. They go, we want them to be Old Spice Girls meets Beyonce at a summer beach party. And they give us a bunch of songs that match that vibe. Next step is feature extraction. All the lyrical, structural, harmonic, and melodic features are extracted from the benchmark songs. Then the benchmark is added as a new class to the training data, and our models are trained. We use an ensemble of classifiers: random forest, nearest neighbor, XGBoost, neural network, and a few more. Now, my friend Talia wakes up one day, full of inspiration, and writes the perfect song for the new image the Spice Girls are building. Of course, it has a refrain and pre-chorus and everything. Talia submits the song, it gets analyzed, and the final score, and then the classifiers predict the relevance of the score to the class of the benchmark. Then we calculate the final score by averaging the different predictions according to the F1 scores of our models. And then the song gets into the Spice Girls queue, according to its score. Then, of course, the Spice Girls love her song, and she becomes rich and famous and lives happily ever after. Or, in case that didn't work out, we can see if maybe her song got a high score in another class and recommend Talia to submit a song to that class. So let's briefly go through what we saw in the talk. We started by talking about motivation. We saw that repetition is a main feature in songs. And we defined our building blocks, chorus and refrain. After that, we talked about how we recognize repetition using Levenshtein distance and how we extract the repetition-based structure and the final lyrical structure. Then we looked at the different song structures and their categorization. And finally, we mentioned a few musical features and so how it's all used by the classifiers and combined into the relevance score at MyPart. And of course, we're hiring. And I'll finish the talk on a personal note. When I was looking for a job, I didn't imagine that my data will be songs and that we will have meetings about type of slang words and musical scales. So basically, don't give up on finding a job that is actually very similar to your hobbies. Yes.
Thank you for this. I was just curious to know if you're trying to monitor for when a suggested song is too similar, it's actually stealing, or is considered to be non-legally similar because it's so similar to something that already exists.
We're not doing that right now, but we are looking for repeated sequences, and there's a legal definition of how long can be the repeated sequence you take from another song. Until 8 notes, it's reference, and from 8 notes, it's stealing. So it's not done right now, but it's in the process. Yes?
Do you have a classifier?
So the question is if we have a classifier for each class, for the Spice Girls, for example. No, we add the Spice Girls as a class to the data, and then we train all the classifiers again. So we have the different classes are the different artists we're looking for songs for.
Yeah.
So the question is, how do we combine the lyrics with the melody, since the lyrics, unfortunately, don't come with timestamps? It's a good question, because it's what I'm working on right now. We're actually using speech-to-text, but it's not best for songs. You can try it, it's pretty funny. And then we're doing, trying to do a sequence alignment to match the lyrics and the transcribed lyrics, and looking for the beginning and the end of each segment of the lyrics. And for the music, we're doing segmentation from a few different tools, and then we're trying to match those two together to get the final structure that you can actually call a segment in the music, the chorus that you defined by the lyrics. The question was, do we share the score with the author of the song? No, but like I said, one of the reasons that we don't want to lose the meaning of our features is that so we could give them feedback that actually says you matched, but for the music you had a good match, but for the lyrics not so much, so maybe you can work on your lyrics and try to submit the song again.
Any success stories?
Any success stories? Not yet. But, start writing songs and we'll get there.
A submission is the lyrics with the music?
Yes, the submission of a song is, it's a demo where you sing, and we also request for the lyrics file.
Maybe you can open it up for lyrics and music separately and then combine them both together.
You can submit also separate parts, but right now we're working mostly on analyzing the combined parts, so it's not as effective. But also you can submit art for like the cover of the song or video for the music video and every kind of art actually. Okay. Thank you.